Good morning, everyone. We are in the Hebrew University of Jerusalem, Faculty of Agriculture, ICP laboratory. We'll make a short tour about this instrument, and I decided to be behind the picture because it's easier to me to explain this way, and our volume will be better. So what you see now on your screen is ICP-OES, inductively coupled plasma optical emission spectrometer by Analytik, Jena, Germany. We bought this instrument in 2018, and until now we work with it successfully. And I'm sure I already explained a lot of details about this instrument on the lectures, but now we'll see it close. So this is an instrument. It's not too big, as you see. Of course, it is equipped by water chiller, by argon supply. Our bottles with argon are outside, of course, and auto sampler with a separate hood. I want you to pay attention to this item because it's very, very important. First of all, for your safety. When you are measuring the acidic samples, mostly samples digested with acid, they contain at least 10% of nitric acid, at least, maybe HCl. And if HCl, you may feel the smell of this acid. The nitric acid has no smell. So if you are working with open vials and sitting hours near the instrument measuring the samples are evaporated, and you are breathing the dangerous acid. So we built this hood by ourselves. We ordered it specifically. It's not a part of deal with Analytik Jena. And this hood has an exhaust system its own. So let's see the main parts of the ICP instrument. We have here auto sampler that takes the liquid from each vial, and peristaltic pump takes our sample by this tube and take it to the sample introduction system. Now let's open our compartment and see all these called sample introduction system. And the first part of this system is concentric nebulizer. You see that here connected the tube with our liquid sample, and here to this part, to this tube, connected the argon supply, and inside the nebulizer here at the end, two flows, liquid and gas, are meeting each other and forming the droplets, fine droplets. And these droplets come to spray chamber, so-called cyclonic spray chamber. Again, here we have an inlet of the droplets, and here we have outlet of the waste. As we said on our lecture, more than 90% of our liquid sample are going to waste. So we use the very small percent of very fine droplets. And with the argon flow that fills all this system inside, our droplets going to the torch. I can't show you this torch without an instrument, but you see this This is a part of the torch. This is a torch body. Inside we have a glass part and several tubes that a torch consists of, also made of borosilicate glass. And this small part called bonnet, it is isolates our plasma from the coil of the generator. So when we open our argon supply and it comes here to torch, and the generator sent a lot of energy via this coil to the gas, and converts our argon gas to its ionized form, to plasma. Here we have plasma. Today I can't switch on the plasma of my instrument. I will show you the peaks later, but believe me, we can do that, of course, with this door closed, and we may see through this black window our plasma that is situated here. And this part, called as in ICP-OES cone, this is a axial view cone, and this is a radial view window. So this instrument is so-called dual view. It may read the signal also from the top of the plasma, and to see through all the way of the plasma, and to see all the species that we have. So this way we get more strong signal, we improve our sensitivity, intensity of our peaks, but we get all interferences, all possible interferences, easily ionized element, and so on and so forth. And the more classic and more free of interferences view we have here. And for some elements that are specifically important to measure them without interferences, but we have high concentration of these elements in the sample, and sensitivity is not so issue here, we may use at the same run, at the same measurement cycle, for the same sample, we may use also radial view. This is programmed in the method. I just select an option, which element, which line to be exact, and I may measure the same element by different lines and different views. So I just select the option, which line to measure by axial view and which line to measure by radial view. Of course, it all costs a bit time, part of second, but if your set of element is about 30 or even more, so it's seconds and minutes. And in this part of the instrument we have our optics. That makes our instrument OES, optical emission spectrometer. This is ICP, this part is ICP, and this part is optical emission spectrometer. And as I said before, this instrument, Analytik Jena optical emission spectrometer, as far as I know, is the only instrument on the market today that is modern, new, and sequential, like before. It has superior sensitivity, great resolution, and it works slowly. There is nothing to do with that. So a few words about regular treatment of the instrument, maintenance that user of this ICP should do on the daily basis, on the weekly basis, before you call an engineer, a technical support to help you. There are several things that you should do by yourself. For example, you should every time check the state of the peristaltic pumps tube, when they are getting old, flatten it, they lose the transparency, especially if your sample contains a lot of acid, high percent of acid. Acid just hits the tubes, and you should replace them. If you work intensively, probably you will replace them once a week, something like that. More or less, that's what I do with our everyday work from morning to evening. All these system is demountable. You may reassemble. You may take out nebulizer, spray chamber, torch, and we should wash the glass parts in aqua regia diluted 2 times, heat it a bit or something like that to dry and to put back. Of course, we should open sometimes this cone, and inside this cone the lens, the glass lens, is sitting. We should take it out and also wash by water, by diluted acid, dry and put back. And also wash this glass window, because if it's not clean, so it sees less intensity, it transmits less light that we need. To this part, the user, we don't touch this optics. If we have problem here, we call help. And you should take into account that even if you washed and clean all sample introduction system, and if you replaced these tubes, there is at least one long tube that you can't replace and put completely new every time you make maintenance. I mean this tube of auto sampler. It goes there, it is pretty long, you see this here, and it is long enough to reach each part of this auto sampler, or maybe larger if you have bigger auto sampler. And this tube is sometimes the source of memory effect. If you run high concentrated samples and after that you washed all your system, put new tubes, and you run blank, and you still see what I call this tail. You see the rest of low concentration of your element, but still it interferes. It is not possible to calibrate instrument to measure very low concentration if we have 0.5 ppm, for example, of sodium or potassium, even this. So for that, because we can't just replace this tube, first of all, it's a bit expensive and it is not possible in the regular basis. So we should wash our instrument during a run and before run and after run by several solutions, in addition to our basic matrix. In our case, this is nitric acid 1%. In addition, I use very diluted solution of Triton X non-cation detergent. So I wash my system by this substance. Then I use sometimes nitric acid more concentrated, 5%, not 1%. I use 10% of nitric acid. This solution should be used carefully because it hits the tubes of peristaltic pump. And Also, every day I use 1% of acetic acid. What acetic acid does, it may catch the cations of elements. Acetic acid is a well-known extractant of the elements from soil, for example. So I use this feature to wash the cations of different elements from my system. And of course, after all these strange and not so compatible to good ICP measurement practice solutions, I should wash out them by 1% of nitric acid, and then my blanks getting much better. So this is more or less our ICP instrument.